So, hello again, this is me, Marges Franco from BSIT 2204. So, for today's video, I would like to discuss to you about the chapter 11, which is switch security configuration. So, let's start. Implement port security. So, security unused port. All switch ports should be secured before the switch is deployed for production use. A simple method that may administration or administrator use to help secure the network from unauthorized access is to disable all unused port on a switch. For example, if is catalyzed 2960 switch has 24 ports and there are 3 fast Ethernet connections in use, it is good practice to disable the 21 unused ports. So, for example, to shut down port for FA or Fast Ethernet 0/8 through Fast Ethernet 0/24 on S1, you would enter the following command. So, that's it. It's the command. Mitigation or mitigate MAC address table attacks. The simplest and most effective method to prevent MAC address table overflow attack is to enable port security. Port security limits the number of valid MAC address allowed on a port. It allows an administrator to manually configure MAC address for a port or to permit the switch to dynamically learn a limited number of MAC address. So, as you can see, that's the example of MAC address. So, enable port security. Notice in the examples, the switch port security commands was rejected. This is because port security can only be configured or manual configure access port or manual configure transport. Trunk port security is beyond the scope of this course. Use the show port security interface command to display the current port security setting for Fast Ethernet 01. So just type the show port security interface and they show you the setting for Fast Ethernet 01. If an active port is configured with the switch port security command and more than one device is connected to that port, the port will transition to the error disable state. This condition is discussed later in topic. So after port security is enabled, other port security specific can be configured as shown in the example. So that's the example, switch port security. Then they're gonna show you the setting of it. Limit and learn MAC address. So the default port security value is 1. The maximum number of the secured MAC address that can be configured depends the switch, and iOS is this example. The maximum is 8192. So that's the code for it. So for port security aging, port security aging can be used to set the aging time for a static and dynamic secure address on a port. Two types of aging are the supported per port. Absolute is the secure addresses on the port are deleted after the specified aging time. So the inactivity, the secure address on the port are deleted only if they are inactive for the specified aging time. The difference between of it is the for the absolute, the port are deleted after a specific aging time. So the inactivity, it deleted the port only if they are inactive for the specified time. So for the use the switch port security aging commands to enable or disable static aging for the secure port or to set the aging time or type. So that's the code, this one. So the parameter for the command are described on the table. Static. Enable aging for statically configured secured addresses on this port. Time specify the aging time for this port. So type absolute. This set the absolute aging time. All the secure address on this port age out exactly after the time. So type inactivity, set the inactivity aging time. The secure addresses on this port age out exactly after 10 minutes. So 10 minutes of inactivity, and by using the show port security interface command to verify configuration. So that's the code for the setting of verifying the configuration. Port security violation modes. Um, this is the code for the port security violation mode. And the security violation mode description: shutdown or default. The port transitions to the error disable state immediately. Turn off the port LED and sends a size log message. It increments the violations counter. So for the restrict, the port drop packets with unknown source addresses until you remove a sufficient number of a source MAC address to drop below the maximum value of increase the maximum value. Protect this is the secured of the security violation modes. So for the security violation mode, that's it. So we're gonna do the next chapter with, sorry, it's mitigation VLAN attacks, which is VLAN hopping attacks can be launched in one of three ways: spoofing DTP message from the attack's host to cause the switch to enter tracking mode, um, introducing a rogue switch, and enable trunking. Another type of VLAN hopping attack is a double tagging or double encapsulated attack. This attack takes advantage of the way hardware on most switch operate. So we have to mitigate VLAN hopping attacks. Oh, that's, you can see it. Disable DTP auto tracking. So for the syntax checker, mitigation VLAN hopping attacks. So for the next is, so DHCP attack review. For the mitigation DHCP attacks, the goal of DHCP starvation attacks is to create a denial of a service for connecting clients. DHCP starvation attack requires an attack tool such as Gobbler. So DHCP attacks is, or DHCP snooping is, does not really on source MAC address. Instead, DHCP snapping determines whether DHCP messages are from an administratively configured trusted or untrusted source. So that's the trusted port or untrusted ports, as you can see. step to implement DHCP snapping. So that's the step of it. The next one is DHCP snapping configuring or configuration example. So the following is an example of how to configure DHCP snapping on S1 or switch 1. So you can see how to do it also. Next is syntax checker mitigation DHCP attacks. So this is the implement DHCP snapping for a switch based on the following topology and special requirements. So the next one is mitigation ARP attacks, dynamic ARP inspection. In a typical ARP attacks, a threat actor can send unsolicited or ARP replies to other hosts at the subnet with the MAC address of the threat actor and the IP address of the default gateway. So that's the dynamic ARP inspection. The implementation guidelines. So as you can see, enable DHCP snapping globally. Snapping on selecting VLANs, selecting die on selecting VLANs, configuring chest interfaces for DHCP snapping and ARP inspection. So die configuration example. As shown in the example, DHA snapping is enabled because DI requires the DHCP snapping binding table to operate. DEX, DHCP snapping, and ARP inspection are enabled for the PCs on VLAN 10. So that's the code. Destination MAC checks the destination MAC address in the internet heading against the target MAC address in ARP body. Source MAC, check the source MAC address in the internet header against the sender MAC address in ARP body. So IP address checks the ARP body for invalid and uninspected IP address include address. The IP ARP inspection validate global configuration command is used to configure the AI to drop ARP packets when the IP address are invalid. So that's so port fast and DPU guard. So recall the network attackers can manipulate the spanning tree protocols to conduct an attack by spoofing the root bridge and change the topology of a network. To mitigate spanning tree protocol, manipulate attacks use port fast and bridge protocol data. So port pass immediately brings an interface configured as an access or trunk port the forwarding state from a blocking state. So PBDU guard immediately error disable a port that received a PBDU. So configure port path. So port paths can be enabled on an interface by using the spanning tree port paths interface configuration command. So port paths can be configured globally on all access port by using the spanning tree port paths default global configuration command. So that's the code for the configuration or configure PBU guard. So this is choose spanning tree summary just to see the setting of it. So the next one is so that's all for um chapter 11, or just called it as switch security configuration. So I hope you enjoyed this video and learn from it. So thank you.